capacitor is a device that has the ability to store charge. This is the electrical symbol, and we can see these two lines represent the two plates, and then we've got the two connections to the external circuit. It's a pictorial view, so again we've got the two plates above and below, and in the middle we've got what they call a dielectric. Now this will be an insulating material. This could be air, paper, even glass, some sort of insulator to keep these two metal plates apart. We can charge a capacitor by connecting it to a battery or some sort of external voltage source. And what will happen when we connect it in the circuit is the negative electrons from the battery will flow around the circuit, and they will sit on the bottom plate of this capacitor. Now these negative electrons will repel the negative electrons from the top plate that are naturally in the material, and it will repel them, and they will be attracted to the positive of the battery. So we get an electron flow from the negative of the battery to the bottom plate, and from the top plate to the positive of the battery. This electron flow carries on until the voltage between these two plates is equal to the voltage of the battery. So if this is just a 1.5 volt battery, this current will flow until this voltage reaches 1.5, or very near the 1.5. We'll see later on that it never actually gets to that value. If we then open the switch, the capacitor can hold that charge. So the switch open, the 1.5 volts is still across that capacitor, and we can leave that capacitor and then come back to it, and we can do work with that voltage. We can connect a lamp, and what will happen then, because we've got a closed circuit again, the electrons that were stored on the bottom plate will move around the circuit through the lamp, turning it on, onto the top plate, and this electron flow will continue until the two values of electrons on the top and the bottom plate cancel each other out. So when there's a balance of electrons, there's no voltage across the capacitor, and therefore this lamp would go off. There are various factors affecting how good the capacitor is. Its capacitance, its ability to store charge. And there's three factors. The first one is the area of the plates. Second one is the distance between the plates. And the third one is the relative permittivity of the dielectric. Now the dielectric is the insulating material between the two plates. And the relative permittivity means relative to a vacuum. We talk about a vacuum being 1 and all other materials being a factor of that 1. Air is very similar to a vacuum, 1.006, so very close to a vacuum. The area of the plates, here's our capacitor, here's our plate. In this case we're just showing the length, which is relative to the area, and this capacitor would have a value of 100 microfarads, for instance. Now if we increase the plate area, so I've doubled the length here, so I've doubled the area, we'll get 200 microfarads, so we'll double the capacitance. If I make the plates smaller, and these are roughly half the original plate size, then we halve the capacitance and we only get 50 microfarads. So increasing the plate size will increase the capacitance, and decreasing the plate size will decrease the capacitance. The distance between the plates is also an important factor. Here's our capacitor again, and I've given it 100 microfarads. Now if we move the plates closer, see this distance is much smaller, I'm saying this distance is half this distance, we'll increase the capacitance to 200. If I move them further apart, I've doubled the distance of this one, goes down to 50 microfarads. So decreasing the distance between the plates increases the capacitance, and increasing decreases it. The permittivity of the dielectric, so as I said earlier, vacuum is our standard value. Again, I've given this 100 microfarads, and you can see on this chart the relative permittivities of different materials. There's vacuum at 1, there's air at 1.0006, paper anywhere between 2 and 6, mica, an oxide film, ceramic, and glass could be anything to 100 times better than a vacuum. So I'm leaving all the dimensions the same here, same plate area, same distance between the plates, but I'm going to change the dielectric to paper, and I'm saying that's got a relative permittivity of 2. So the capacitance value is going to double. We're going to go from 100 microfarads to 200 microfarads just by replacing that vacuum with paper. If I then put a different material in, such as glass, which is, I'm saying, has got a relative permittivity of 10, we're going to go up to 1000 microfarads. So you can see the material we use for the dielectric has a big effect on the capacitance. Higher value of relative permittivity will increase capacitance. So just to recap, the factors affecting capacitance: size of plates, distance between the plates, and the permittivity of the dielectric.